in a normally distributed set of data, with a mean of 140 and a standard deviation of 16, between what two values would you find the middle 95%? Or you might be asked the middle 68%. Or you might be asked the middle 99.7%. Those are the three types of questions. So they can ask you one of the three types of questions they can ask you after this. What you would then need to do is either have, bless you, a good idea of what a normal distribution curve looks like, but more importantly, all you really need to know is what the scale looks like. Because you know at this particular point that this is where 140 is positioned, in the center of the data. And you know that every time you take a step, it's 16 units, so that first step would take you to 156. And when you took that second step out there, that would take you to 172. And if you took steps backward, that would take you to 124. And if you took a second step backward, that would take you to a value of 108. You could actually just draw a number line and start counting in increments of 16 to be able to answer a question like this. So now you know that between 108 and 172, we're going to find 95% of the data. Now, if you don't want to draw pictures, you have a second option, which is to do the arithmetic, but the arithmetic is nothing more than repeated additions, an extra step for every standard deviation they give you, or if you want, since you don't like to do repeated additions, you might break it into a multiplication problem. It can be that simple for the vast majority of your exercises. I would not suggest that you want to waste your time drawing the whole curve, but I would suggest that drawing the scale would be a pretty easy way to be able to do these things. It doesn't take much to be able to do that. Okay, so if I came forward a screen, here's the same problem. Now remember, there's nothing magic about this. This is just simple old basic arithmetic. If I draw a number line, if I draw a line, I don't even have to have it scaled very well. It doesn't have to be a pretty line. It doesn't have to be a straight line. It could be a wobbly line if you're like me. You can't draw a straight line for a hill of beans. And I don't have to worry about the scale being exactly the same distance apart in these cases. I'm not measuring these things with a ruler. I'm using this simply to be able to say, here's one step, how much distance have I traveled? Here's the second step, how much distance have I traveled? Where am I now? Where am I now? Can you read me now? Can you see me now? That kind of thing. So in this particular case, there's my first step involved in the problem. And there's my second step. So I just hit my target value at the top end. There's my first step backward. There's my second step backward. There's my target step at that point. I don't need a curve. I need to be able to see in my head or on paper what this relationship of steps versus distance happens to be. Back of your mind, front of your mind. Not the back of your mind, front of your mind. A standard deviation is a standard size step, and it'll change from problem to problem. But it doesn't change the fact that it's one step. Okay? So some people take bigger steps than others. And we're all going to get the same number because we interpret it the same way. So here's a typical type of problem. Determine the number of standard deviations, also known as a z-score or a standard score, that the observed value of 100 is from the mean. And then they got to give you the mean and the standard deviation. So where's the center of this data's universe? 140. Let's say it's there. And how large is each step? 16 units. So standard deviation is 16. Where's 100? Back here somewhere, right? We really don't know where it is yet. But we can get a pretty good idea pretty quickly, can't we? So instead of moving to the right, should I be moving to the left? Because my target value is smaller than 140. So one full step back to the left would take me to 124. A second step back to the left would take me to 108. And now I know that 100, and the third step back is going to take me to 92. So what does that tell you about our target value? We overshot, didn't we? We missed our exit on the interstate. Now we got to go back, we got to turn around and come back somewhere along the line. Where do I want to be at the end of the problem? I want to be at 100. So one way of asking yourself and tackling the problems this way, and you ask yourself the question, how far from 108 is 100? Answer to that is 8 units. I don't know whether I'm measuring inches, feet, degrees Fahrenheit, whatever. I don't know what I'm measuring in there, but there's 8 units in there. Second question, what part of a standard step is that? It's 8 parts out of a 16 unit step. Or in other words, it's a 1/2 value, or it's a 0.5. You're going to find that they're not going to give you very many values that will give you fractions that they ask for, but whatever numbers they give you are either going to be nicely divisible by halves, or by the standard deviation being a 10 or a 20, so you get nice decimal values out there, so you shouldn't be faced with having to worry about rounding off in here. That'll be nice. So I took one full, I took a second full step, I took a half of a step. So I have moved to get to that particular point, to get to this target value, I have moved to 0.5 standard deviations. I moved in a negative direction, but they didn't ask me what direction I moved, they just said, how many steps did you take? So some of the problems will ask you to enter your answer as a positive number, even though you moved in a negative direction. Now that's one way to do it. Some of you are going to tire of drawing lines and drawing pictures pretty quickly. Some of you are going to say, that's pretty neat, I can do that. Some of you will go back and you'll look at it from more of a formula standpoint. So second option out here would be something like this. How far from where you want to be is the mean? Maybe we want to do that all in one step. How far from the mean am I if I'm at 100? Well, I would have 140, and I would take away 100, and that would come up with 40. So I'm 40 units away. Second question, how many standard steps is that? Which would now mean I'm comparing that to the size of a standard step. And if I'm comparing that to the size of a standard step, my calculator will tell me that if I take a value of 40 and I divide it by 16, then I'm going to come up with 2.5. You have four choices here. Choice number one, that's too hard. I'm going to miss that one. You're in trouble. Choice number two, I'm going to guess. Not a good idea. Choice number three, I'm going to draw pretty pictures so I can put them on my refrigerator at home and have my parents tell me they're proud of me. That floats your boat, float your boat. And some of you, I'm not drawing pictures, but I can absorb the concept and just look at the numbers and talk about total distances instead of breaking it up into pieces. Quite literally, I don't care, as long as you absorb the concept. Sometimes you're not going to see full standard deviation steps,